So I'm just going to preface this video by saying that if you hear a bunch of really strange noises in the background, that would be my kitten, which, yeah, this is her favorite time of day to make a bunch of noise. And I'm not at work while I'm doing this. I'm at home, so there you have that. So let's talk about the inverse sine function. So before we can talk about inverse sine, let's just talk about the sine function. So we have f of x is equal to the sine of x. And if we graph this, it looks like this. So let me see if I can at least approximate this, and so on and so forth. Let's actually zoom up on this for a second and get a better look. Okay, so the sine of 0 is 0, so it goes through the point 0, 0. And then sine has a period of 2 pi, so this point here is 2 pi. It's also 0 at pi. This is pi over 2, and this point right here is pi over, oops, that's incorrect. It's 3 pi over 2. 3 pi over 2. And then we get the same pattern back the other way, right? So this is minus pi, and this is minus 2 pi. If I could make what I'm writing actually show up, 2 pi. Okay, so the issue here, though, is obviously that we can't just invert the sine function, because the sine function is not one-to-one. It does not pass the horizontal line test. So what we do instead is we restrict the sine function to the largest piece we can possibly get. So we're going to take this and we're going to chop a bunch of it off. And we want to get the largest interval we possibly can on which the function is still one-to-one. And so if we look here around 0, we can include everything from here all the way up to there. But if we include any more, oh, let's try this again. So from here all the way up to here. If we include any more, it won't be a one-to-one function because we won't pass the horizontal line test. So what we end up doing is actually just like throwing the rest of it out. And so we take the domain to be from minus pi over 2 to pi over 2. And the range of the sine function to be from -1 to 1. This means when we invert this, we're going to interchange our domain and range. So when we write down the inverse sine function, which is also known as the arcsine function, the arcsine function will have the domain and range flipped from here. So when we look at arcsine, the domain is going to be -1 to 1, and the range is going to be minus pi over 2 to pi over 2. Because I'm a really visual person, I like to remember that if I'm looking at the quadrants, like here's 0, pi over 2, pi, and so forth, 3 pi over 2. 3 pi over 2 is the same thing as minus pi over 2. So the range of inverse sine is in the first and fourth quadrants. So from minus pi over 2 to pi over 2. So where were we talking? So inverse sine. So now if we graph the inverse sine function, let's see here. Let me get my pen back. We take Remember over here, we take this function and we flip it. Let's try this again. We take this function right here and we flip it over the line y equals x. We interchange all of our x and y values. So that looks like this a little bit. And I'm not doing a very good job of drawing it. Looks like that, right? When we interchange all of our x and y values. There's a better picture of it in the handouts. But that covers the domain and range of arcsine. So let's do an example. An example will be helpful or instructive. So, example. Let's find the inverse sine of minus the square root of 3 over 2. So the first thing we want to think of is, where is the sine function equal to the square root of 3 over 2? Well, I always have to think back to the different triangles. So a side. Since the opposite side is the square root of 3, and the hypotenuse side is 2, that means my missing side is 1. And which triangle is this? This is the pi over 3 triangle. So this is some multiple of pi over 3. Now, where is that going to be negative, in which quadrant? So we learned that all students take calculus, and so the sine is negative in this quadrant, and inverse sine will always give me a value between pi over 2 and minus pi over 2. So I'm looking for the value in here. So this is going to be minus pi over 3. And this works because the sine of minus pi over 3 is minus the square root of 3 over 2, and negative pi over 2 is less than or equal to minus pi over 3 is less than or equal to pi over 2. So the range is in the correct quadrant.